As you might have noticed, a lot of graphene's wonder capabilities are currently limited by its production methods. Up next, we have a key to discuss the future of mass production of graphene.
Thank you, Matt. So as you've heard from the previous speakers, graphene has an immense potential to revolutionize a variety of technological markets. Researchers are therefore working hard to ramp up commercial graphene production in order to meet the growing demand for this wonder material. The cellophane tape method mentioned earlier earned Gaiman Novoselov the Nobel Prize in 2010 and was a groundbreaking demonstration that it is indeed possible to successfully isolate stable monolayers of graphene. Unfortunately, this manual tape method is slow, tedious, and difficult to scale toward mass production. So researchers are now racing to develop alternative methods to efficiently mass-produce graphene. The challenge has been to find reliable methods that can achieve all the criteria of quality, sheet size, purity, cost, and scalability. Some researchers have adapted Gaiman Novoselov's concepts, isolating graphene from its natural source, graphite. A benefit to this methodology is that the pure graphene is already naturally present within the graphite, but the challenge is to isolate the monolayers from that block of graphite while maintaining sheet size and without introducing additional impurities. Researchers at Penn State have developed a method to pry apart the layers of graphene using ions. Unlike previous intercalating methods, this one doesn't require harsh acids or oxidizing agents, therefore preserving the purity and integrity of the final graphene product. On a similar thread, Cambridge Nanosystems has pioneered a method to separate the graphene layers within graphite using plasma-based cracking of methane gases. Unlike other methods of methane cracking, this doesn't require additional catalysts, and therefore allows for the isolation of highly purified graphene from its graphite precursor. Still, the derivation of graphene from natural graphite is associated with some limitations. It is still relatively difficult to scale up for commercial mass production, and there are restrictions in the achievable sheet size. Therefore, other researchers are attacking this problem of graphene production from a different angle by using carbon atoms to grow graphene in the lab from its component molecular pieces. Graphene, one of the largest suppliers of graphene, has piloted a method of depositing carbon onto a surrogate honeycomb lattice structure, allowing for the de novo formation of synthetic graphene flakes. These methods of generating graphene from scratch can yield fairly high levels and purity of graphene, but can unfortunately also consume a large amount of energy and produce a variety of waste products. Moreover, these de novo growing methods have only previously been capable of producing large sheets of polycrystalline graphene, which is limited in its uses compared to the monocrystalline form. This distinction of polycrystalline versus monocrystalline graphene is integral to the graphene mass production process. The early methods of growing graphene were only capable of producing small disjointed graphene crystals, or what is referred to as polycrystalline graphene. While polycrystalline graphene has a number of useful properties, the best qualities of graphene are found in large, uniform sheets of monocrystalline graphene. It's only in the monocrystalline form that graphene fully exhibits its phenomenal electrical and mechanical properties. And it's for this reason that a cheap and rapid method of growing large sheets of pure monocrystalline graphene is the current holy grail of graphene mass production. Samsung has recently unveiled a new method of producing monocrystalline synthetic graphene. Their method involves chemical vapor deposition of carbon atoms onto silicon wafers coated with germanium. The germanium here is the key. It provides a unidirectional substrate so that graphene crystals also grow unidirectionally and eventually fuse into one large monocrystalline layer. This method is highly scalable and capable of rapidly generating very pure, large monolayers of graphene monocrystals. The silicone wafers and germanium can then be reused, therefore dramatically reducing waste, especially when compared to previous chemical deposition techniques. Methods such as these are poised to revolutionize the rapidly increasing number of industries and technologies that rely on graphene availability, particularly because the cost-effective mass production of this wonder material has long been a major roadblock for the graphene market. And with that, I'd like to pass the discussion on to Justin, who will talk a little bit more about the future of the graphene market.
Thanks, Aki. So I'm really pleased the presentation is structured in this way because a discussion of ways of fabricating graphene, especially advances in production methods, is a really nice segue into what the future of graphene looks like in terms of its application to industries. So this is a graph from a company, a vendor of graphene, called Graphene Frontiers, of the predicted market for graphene in the next few years. And you'll recall we showed an earlier graph. Charlie discussed it at the beginning of the presentation, showing while graphene is predicted to grow significantly in the years ahead, his graph showed a more gradual trend, right? Almost a linear or an exponential increase. Whereas this graph from Graphene Frontiers really shows a striking jump from a market of $52 million for graphene films and sheets in 2012 all the way up to a multi-billion-dollar market in 2016. It's almost a binary switch where something toggles an immediate change in the value of graphene. And the reason that Graphene Frontiers has such a widely different model of the graphene market than the typical industry survey we showed at the beginning of the presentation is because having intimate knowledge of the challenges that graphene fabrication is facing can let you make a better prediction about the direction the market's going to take. So, for example, Graphene Frontiers is very aware of the challenges being faced in graphene production. They know about the issues with monocrystalline versus polycrystalline graphene, but they're also aware that once those challenges are overcome and once some of the new synthesis methods Aki spoke about on the previous slides come into play, the price of graphene is going to drop by several orders of magnitude, making it possible to integrate not just into high-tech industries where graphene can be part of premier luxury products like foldable electronics, but even into industries where graphene could be almost disposable. The cost of the raw material should increase dramatically, and that, in turn, will account for the rapid growth in market share that Graphene Frontiers predicts. So with that in mind, just a question for the audience. What industries do you think will be most impacted by graphene? So I know we have a number of industry folks here today. Just curious what your impression is, what graphene is going to impact in the near to midterm. And we tried to capture some of the most common industries that our attendees would have based on your registrations for the webinar. So take another few seconds to vote in the poll. Which industries will be most impacted? Note you can vote from multiple options. And then let's take a look at the results. Yeah, so I see that the crowd has a clear preference for high-tech defense and aerospace materials. And that's really no surprise, right? Logic tells us that advanced materials often find a home first in these sectors that can pay more for them, high-tech defense and aerospace industries. But the question really is a trick question because we're predicting that all industries will be impacted by graphene in the near future, in part due to that rapid drop in price we're expecting to see in the next few years. So this poll, there was no wrong answer. All of those industries will be impacted by graphene. So the next slide really hammers that point home. The chart at the top right corner of the slide shows almost a pie chart of industries that are going to be impacted by graphene. And you can see the biggest slices in the pie chart, of course, are semiconductors and electronics, energy, composite materials, and that should make sense considering the information we talked about earlier today, right? We talked about those specific devices. We talked about those electronics. The use cases for graphene really the coolest developments are really the semiconductors and electronics. But, graphene is going to impact a number of industries that are less flashy. And if you look at the smaller slivers on the pie chart, you can see the marine industry, construction industry, sporting goods, antibacterial products industry. These mature, smaller niche industries are expected to be impacted by graphene, in a way that maybe not to the same magnitude as the larger industries, but it really shows that no sector of the market is going to be unscathed when graphene, really hits the ground. It's been called a wonder material, and if you think back to the last material that was really called a wonder material, it's plastics, right? When polymers were invented in the 1920s, 30s, and 40s and gained popularity, they were called a wonder material. They were lightweight, they had amazing properties, and at first their impact was predicted just to be in packaging, right? We'll replace glass bottles and metal containers with this wonderful plastic, but as time went on, the impact of plastic has really transformed all industries, right? I'm looking at my desk, I see a phone made out of plastic, monitor housing made out of plastic, mouse made out of plastic. Everything in my room right now has a component of plastic in it. The properties of graphene are orders of magnitude more impressive than plastic, and as a result, their impact is going to be just as widespread, if not more. The flowchart on the bottom really shows that there's a global component to this as well. The vendors of machines that make graphene and process graphene are located in North America and the European Union. We have suppliers of graphite ore that's further refined into graphene, focused in Canada, fabricators of graphene all over the United States and Europe, as well as some vendors in Asia. And you can see that the end users of graphene are some companies that we all are aware of, major players in their industries, BASF, IBM, Nokia, Samsung, companies that definitely have a global footprint. So the impact of graphene is not going to be something that's relative to a specific market or a specific region of the world. Even though some regions are funding it more than others, when graphene catches fire and really gains momentum, it's going to spread rapidly across multiple sectors. The other big misconception is that graphene is not going to have an impact for a while. And this graph is from a paper in Nature Nanotechnology. And it shows the various applications of graphene sort of ranked by technology readiness level. So technology readiness level shows how close the technology is to commercialization. The low end of the spectrum, TRLs of 1, 2, and 3 are technologies still in the lab. At the middle end of the spectrum, we have some technologies that are being prototyped. And 7, 8, and 9, the high end of the spectrum, are technologies leaving the lab getting ready for commercialization. And you can see there's technologies using graphene that are commercially available right now, right? If you buy electron microscopy supplies from Ted Pella or other vendors, you can get films for TEM grids that have graphene in them. So there's products today that are already using this wonder material. The other products we talked about, these flexible electronics, flexible conductors, photodetectors, humidity sensors, those are also at the mid to high end range of the TRL spectrum. So that means companies like Samsung are producing these flexible displays, but they're not just displays confined to laboratory testing. They're producing hundreds and thousands of these displays and sending them to developers so they can start exploring applications of them. So they really are about to hit broader commercialization. They're not just a product of R&D sitting in a laboratory, collecting dust on a shelf. They're getting out there and being seen by multiple people. At the low end of the spectrum, yes, DNA sequencers, filtration systems, optoelectronics, those devices using graphene are probably quite a few years away, but it really shows the broad range of industries that are going to be impacted by graphene, as well as the fact that those impacts have already started and are only going to accelerate. So the question people ask us a lot at Prescouter is if graphene is going to impact their industry, and I challenge you to reframe that question and don't think about if graphene will impact your industry, but rather when, right? You should be researching a program to implement graphene into your current products. You should be getting ready to incorporate this wonderful material because if you aren't going down that road, there's a strong likelihood that your competitors are. So that brings me to a brief discussion of our print report. And remember, this webinar is sort of a snapshot of some of the content you'll find in the print report, a high-level overview of graphene for people without a materials science background. Our print report goes into a much higher level of detail. Specifically, it includes sections on graphene's impact on multiple specific industries, including food and beverage, manufacturing, pharmaceuticals, and electronics. It's also got some sections that show how graphene is going to impact the marketplace in a broader perspective. So how graphene can maybe impact material science that will then be leveraged by multiple industries. So if your industry is not represented in that list, our report will still have some suggestions on how you can take advantage of graphene regardless of what specific sector you're in. Though we do have some nice case studies from some industries in particular. We're also very pleased to announce we have an exclusive interview with the Scientific of Graphene, which is one of the European Union's largest producers of graphene. The scientific director of Graphene gave us some really nice insights into her predictions for the future of the graphene market, some insights into funding from the European Union applied research programs, as well as a roadmap for the specific hurdles that someone should look out for to know that graphene is about to catch critical mass. So we know there's these challenges in the laboratory. What are going to be the first signs that show that these challenges have been overcome and the widespread use of graphene is imminent? So the report has a lot of value. If you're interested in ordering the report, webinar@prescouter.com is the address to contact. It's located